Now we're going to look at pyramids and cones. We're putting pyramids and cones together because they have a very similar structure in the same way that prisms and cylinders do. A pyramid is a solid where one face, the base, can be any polygon, and then the other faces are all triangles. So if you look at this hexagonal pyramid here, it has a base that's a hexagon, and then every other side, all the other faces are all triangles. Those faces are called the lateral faces, and they all meet at a vertex. We have a lateral edge and an altitude. When we talk about the height of our pyramid, we're talking about the altitude. And the altitude and height are always perpendicular to the base. Here, we can also talk about slant height. Slant height, we're going to use the letter cursive L to designate it, and it is the distance from the vertex to one of the edges where it meets the edge at a 90-degree angle. The slant height and the height are very different. And if you look, if I start connecting slant height, and the apothem, we end up forming a right triangle, which will be very useful to us later. So you know a trig is coming. The shortest distance from the vertex to the base is called the altitude, and the distance from the base along a lateral face of the pyramid is called the slant height. So moving right along. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are all congruent isosceles triangles. The lateral area of our pyramid is the sum of the lateral sides. Remember, those lateral sides will always be triangles. So in a pyramid, if you look, the lateral area is going to be equal to all these triangles put together, and each triangle has a side and a slant height. So the area of one triangle, well, that does not look like a 1. The area of one triangle, work for me, would be 1/2 side length times slant height. Well, if you look, if I have 4 of these, they all have the same slant height, but their side lengths may or may not be different, but we could add them together to form the perimeter. So my lateral area is just equal to 1/2 of the perimeter times the slant height. And my surface area is equal to the base plus the lateral area. So that's base plus 1/2 of the perimeter times the slant height. Let's do an example. Here, I have a slant height of 8. My perimeter, we have a hexagon, and each side length is 4, so it's 4 times 6, which would be 24. So I'm able now to go ahead and get the lateral area. The lateral area is the perimeter times the slant height. And I don't know what 24 times 8 is, but we will find out really fast. 24 times 8 is 192. So the lateral area is 192 meters squared. Now I'm going to get the surface area, and all I need for the surface area now is just to add in this base down here. This base is a hexagon. It's a regular hexagon, so I'm going to use the formula area equals perimeter times apothem divided by 2. My perimeter we already found is 24. The apothem has been marked as 2 square root 3 divided by 2. 2's cancel. I end up with just 24 square root of 3. So my surface area is the base, 24 square root of 3, plus the lateral area, 192. And that's meters squared. And yes, you can leave your answers like this because this is the most simplified form. And it's the most accurate answer. If I put this into my calculator, I'd only get an approximate answer. Okay, let's look at another problem now. Okay, here we have a square pyramid because my bases are both 4. We do not have a slant height, so that's something we're going to have to work on. But I do know that the height is 6. So I'm going to work on finding the slant height first. I'm going to draw in the triangle here as best I can. It may not go very well, but we're trying. And, you know, let's redraw it to the side, shall we? Let's see. There we go. So here we've got this is a 90-degree angle. I know that the height is 6. Now be very careful because this bit right here is not 4, it's half of that, it's 2. And I'm looking for my slant height here, L. So I'm going to use Pythagorean theorem. L squared equals 6 squared plus 2 squared, or that's equal to 36 plus 4. So L squared is equal to 40, and I want to take the square root of everything. 40 is 4 times 10, where 10 is 5 times 2. So I can take a 2 out of this from the 4 and be left with the square root of 10 on the inside. So that's my slant height. So now if I want my lateral area, it's equal to 1/2 perimeter times slant height. My perimeter, each side is 4 and there are 4 sides. 4 times 4 is 16, times slant height is 2 root 10. The 1/2 and the 2 cancel, and I'm left with 16 square root of 10 for my lateral area. Now I just need the surface area, which is equal to base plus lateral area. And in this case, the base is a perfect square. It's 4 times 4, so it's just 16 plus 16 square root 10. And again, my units are meters squared. And this is the simplest form of that answer, so I'm going to leave it just like that. Okay, we put cones in here because they're very similar. They're just like pyramids, but now rather than having a polygon for the base, you have a circle. And so, just like before, we have a slant height, we have an altitude, which is called the height. We use h to designate it. And we have a radius, and the radius goes from the center of the base to the outside edge of the base. We still have a vertex. The area of the lateral face is a little bit different. It's actually an arc. And if you find this area right here, this edge here, is the circumference of the circle because it lines up perfectly with the circle. And this is the height, so what it ends up being, your lateral edge is 1/2 of 2 pi r times the slant height, because it's a portion of it. It ends up just being pi rl when you simplify it. Now my surface area, we throw another pi r squared in for the base. So it's base plus lateral area, pi r squared plus pi rl. So let's do some examples. All right, here I want to get lateral area, which is pi rl. Well, I know that r is 3 in this picture. I don't have l. But what I do have is a really beautiful right triangle, where one side's 3, one side's 4. That's a 3, 4, 5 triangle. The hypotenuse must be 5. So my L is 5. So when I plug in, I get pi times 3 times 5. Lateral area is 15 pi. Now my surface area is, as always, the base plus lateral area. Well, my base is pi r squared. The lateral area was pi r slant height. So we do pi times 3 squared plus, we already found the lateral area, which was 15 pi. This ends up being 9 pi plus 15 pi, which gets me 24 pi centimeters squared as my surface area. All right. Here, they give me the slant height and they give me the diameter. Well, I don't want diameter, I want radius. My radius here is 3. So if I want to get the lateral area, that's equal to pi r l, where L is the slant height. I do pi times 3 times 8. That's just 24 pi. Now my surface area equals the base plus the lateral area. The surface area is going to be pi times 3 squared plus 24 pi, this being the radius of the base, and I end up getting 9 pi plus 24 pi, which gets me 33 pi feet squared.